Alright, today we are doing 6.2 inverse trig functions. We're going to go backwards, guys. We're going to figure out what degree makes the value. So at the first part here, it just reminds you of what inverse actually means. So to find an inverse, we switch x and y, and we solve for y. So if we were to find the inverse of sine x, I would switch x and y and then solve. Of course, to get rid of the trig function and only keep y, you would do the inverse trig function. These are other ways to represent the inverse trig. Arc sine, arc cosine, arc tangent. You'll see these mostly during calculus, but for now we're going to use the inverse. Many of you have dealt with the inverse functions before, but remember, we are doing this without a calculator. So make sure you have your unit circle handy. And now we're going to work backwards. Okay, so first of all, if you remember, if you talk about a function, that means that it will do a vertical line test. Okay? An inverse function, it's we flip x and y. But as you can see, if we flipped x and y here and we turn this graph, we would no longer have a function because you cannot do the vertical line test. So if you remember correctly, when you think of inverse on a regular graph, you can do the horizontal line test. So what they did to make sure this is able to work is they restrict the domain for sine. So for sine, we're restricting it from pi, negative pi over 2 to pi over 2. So right here where it is darkened. Okay? Which also means that we are only using quadrant 1 and 4. And this is the graph of that restriction. For cosine, as you can see, we can't go from negative pi over 2 to pi over 2 because we would still not have a function. So we have to restrict it from 0 to pi. Okay. If you look at your unit circle, 0 to pi is quadrant 1 and quadrant 2. So just to remind you, on your unit circle, we are using for sine, we are using quadrant 1 and 4. For cosine, we are using quadrant 1 and 2. Now let's look at tangent. Tangent, we also have an issue, but we have to restrict it from negative pi over 2 to pi over 2, which again, like sine, has us do quadrant 1 and 4. So on your unit circle, you are only looking at these two quadrants. What does that really mean? You'll see in about a minute. I'm not going to have you write down quadrant 1 just for the fact that you should have your unit circle with you. Okay. Alright, so what do these questions look like? What we're going to do is find the exact value without a calculator. So we want to find out where sine would equal to square root of 2 over 2. Okay. Pull out your unit circle. Now, think of your domain. We only use quadrant 1 and 4. So I'm going to cover this up. If we're looking for the square root of 2 over 2 for sine, remember that the coordinate sine is in the second place. So where is the only place that we have square root of 2 over 2 for the second coordinate. Right there. We're always going to write these in radians, so the radian is pi over 4. B. We have sine again, so cover up that left side. And when we're looking for a negative square root of 3 over 2. So, cover up the left side, look for a negative square root of 3 over 2. Right there. Everybody find it? Now, of course, you're tempted to write 5 pi over 3. But here's the issue. If I start at 0 and I went to 5 pi over 3, I would be going counterclockwise to get to 5 pi over 3. That's 300 degrees. But what happens is we run into the domain restriction. That's why I have you guys put your hand there. So how do we get here without going into my hand? Well, the way to do that is to go counterclockwise. So we got to figure out what is this degree going backwards. Last class we learned about negative the degree or negative the radian. So if we look and we reflect, 5 pi over 3 is same thing as pi over 3. But since we are going counterclockwise, it is going to be negative pi over 3. Again, it's because we cannot go counterclockwise. We have to go clockwise, which makes us go backwards. All right, let's practice some cosine. Cosine, what quadrants do we look at? Hopefully, you said quadrant 1 and 2. So we're covering the bottom. Okay, we're covering the bottom. We want to find where it's 1/2. So, cosine is what part of your coordinate pair? It is your first one. So, where is it 1/2? Positive 1/2. It is positive 1/2 right there at pi over 3. Okay, cosine negative square root of 2 over 2. Cover that bottom. First coordinate, negative square root of 2 over 2, right there. Now 3 pi over 4. Remember what sign we ran into that we couldn't go counterclockwise because we ran into the domain restriction? Well, here, if we go to 3 pi over 4, did we run into a problem? Nope, I could get there just fine. So my answer is 3 pi over 4. All right, tangent. Now to do tangent, guys, you really want to have your tangent stuff down. So what I would do is quickly copy my unit circle, and as you can see, I put my tangent stuff on the outside. Undefined, negative square root of 3 over 3, negative square root of 3, negative 1, negative square root of 3 over 3. This is 0. Square root of 3 over 3, 1, square root of 3, undefined, negative square root of 3, negative 1, negative square root of 3 over 3, and 0. Because if you remember, tangent is sine over cosine. If you have to do that, go back, pause the video, and write those down. But right now I'm going to continue. So we're going to find where tangent is 1. So, tangent. Do you remember what sides that you cover up? Tangent only uses 1 and 4. So I'm going to cover up that left side. And again, I'm looking for the value of 1. There it is. I want to make sure. Yep, we're good. So it's 1 right there. Where is it 1? Pi over 4. Next one. Negative square root of 3 over 3. Alright. Find negative square root of 3 over 3 on your unit circle. Found it right here. Now, that's 11 pi over 6. But we run into that situation like we do with sine. If I went to 11 pi over 6, I run into my hand. I run into that domain restriction. So actually, I have to go clockwise to get there. So the question is, how much did I go clockwise? I can look at the reflection. This radian is the same thing as this radian. Same place. But of course, instead of going positive that way, I'm going to go negative. So it is negative pi over 6. In example 2, we are going to do some compositions. So work inside out. For A, one of the things I want you to see is 0.03 would be in the first quadrant, which is great because for inverses, sine is quadrant 1 and quadrant 4. And because sine and inverse sine are inverses, our answer is 0.3. For B, we don't have this quality because 7 pi over 6 is in the third quadrant, which cosine cannot happen. So we have to work our way inside out. So the first thing I want you to do is tell me what cosine 7 pi over 6 is. Look at your unit circle. 7 pi over 6. Cosine is going to be negative square root of 3 over 2. So as of right now, we have inverse cosine of negative square root of 3 over 2. When we find the inverse, cover up the bottom for cosine and find where cosine is negative square root of 3 over 2. Just right here. So the answer is 5 pi over 6. Same thing for tangent. What we're going to do is find tangent pi. So if you go to your pi, tangent is 0. And then the inverse of 0 is 0. So you remember that tangent pi equals 0, and then we have to cover up the left side and find where tangent equals 0, which is right at 0. D is a little bit trickier, but what we can do is remember the property we learned in 6.1. Cosine negative is the same thing as cosine positive. So I'm going to change this to positive these two equal? Now I can see that these two will cancel. 1.1, since we are okay in the quadrant we need to be in, which is the second quadrant. In example 3, we are still doing compositions, but as you can see, 5/13 is not in our unit circle. But what we're going to do is draw a right triangle to help us solve. Cosine is adjacent over hypotenuse. So if our inside angle is there, that means the adjacent side is 5 and the hypotenuse is 13. That allows us to solve for tangent now. But tangent is opposite over adjacent. So what we must do is use the Pythagorean theorem to find our opposite side. So I have 5 squared plus a squared equals 13 squared. If we solve for a, we will get 12. So in other words, for a, our composition is 12 over 5. We can do that again, but let's remember that we're dealing with a negative, and sine being negative, we're going to make our triangle down. Okay, there's our degree. Sine is opposite over hypotenuse. Opposite side being -1, hypotenuse being 4. We're doing cosine. Cosine is adjacent over hypotenuse. So we need to use the Pythagorean theorem again. So a squared plus -1 squared equals 4 squared. When we solve for this, we get square root of 15. If you are having trouble with the Pythagorean theorem, stop the video and call me over. This gives our answer to be the square root of 15 all over 4. This one's going to be like your level 4 because our answer is going to be in variable form. So I'm going to draw my triangle. Cosine again is adjacent over hypotenuse, so it's going to be x over 1. Use the Pythagorean theorem to find your missing side. So we'll go a squared plus x squared equals 1 squared. So a squared equals 1 minus x squared. Get rid of the square, we get a equals the square root of 1 minus x squared. The last part of the composition is sine. So sine of that degree is going to be opposite, which is the square root of 1 minus x squared, all over 1. Alright, you may continue on your homework.